doing good. This session on OOPS concepts will help you sharpen your coding skills. In my previous video, we learned about concepts like classes and object, encapsulation, inheritance, and polymorphism. In this video, we will deep dive into concepts because as per me and what I have seen in software industry, the solid foundation will help you a lot in your coding journey. In my future videos on some advanced topic in data structures, I will assume that you already have knowledge about these concepts. The main aim of object oriented programming is to implement real world entities like pen, chair, table, computer, watch, and the list goes on. What the takeaway in here is that in our day to day life, we come across products that we can use as they have some utility that is useful, especially through being able to perform several functions. To learn more about classes and object encapsulation, inheritance, and polymorphism, go to the video link provided above. In nutshell, class is all we need to understand, and objects are nothing but instance of class that resides in memory to do computations. Example: a dog is an object because it has states like color, name, breed, etc., as well as behaviors like wagging the tail, barking, eating, etc. This whole classes and objects and the different concepts that we are learning, what it does is it simplifies software development and maintenance as it is close to our everyday life. Now, let's move to the concept itself. Our first concept is abstraction. Hiding internal details and showing functionality is known as abstraction. For example, having a phone call. We don't know the internal processing, but we always talk to each other on phone calls. And the other example that I can remember is a car. You're driving a car. You don't know the internal processing, but you are using the car. Now, let's move to another concept, and that is called coupling. Coupling refers to the knowledge or information or dependencies of another class. It arises when classes are aware of each other. If a class has the detailed information of another class, there is a strong coupling. In Java, we use access specifiers, that is, public, private, protected, to specify the visibility level of a class. It can be for a class, it can be for a method and fields. You can use interface for the weaker coupling because there is no concrete implementation. In the diagram that we are seeing on the left hand side, you have circles that are basically what they are representing is that there is the foundation, not a foundation. There is a overlap that you can see, and in this overlap, the what is happening in here is the dependency. It shows dependencies. It means same thing is there, or it is a very tight thing. So what it is dependent showing is more interdependencies, more coordination, more information flow, right? And on the right hand side, you see there are the circles are not overlapping; they are different, but there is a what I can say there is an information flow. So what it represents is less interdependency, less coordination, and less information flow, right? So we are able to understand this. Now let's move to another part. The other part is module coupling. When I say module coupling, as you can see in this particular image, the first one A is you have no dependencies. B, you have limited. Okay, like the first one is having only one arrow to right. But on the C part, everything is too much. We are having too much dependencies, right? So now we also got what coupling is. Now let's move to another concept that is called cohesion. Cohesion refers to the level of component which performs a single well-defined task. A single well-defined task is done by a highly cohesive method. The weakly cohesive methods will split the task into separate parts. The Java.io package is a highly cohesive package because it has IO related classes and interfaces. However, the Java.util package is a weakly cohesive package because it has unrelated classes and interfaces. So the cohesion also, we're able to get what a cohesion is, right? Now let's move to association. What is association, right? So first get let's get on to that. So association represents the relationship between objects. Here, one object can be associated with one object or many objects, right? So to understand this, let's go into how many type of associations can be. So the first one is one to one to many to one, and many to many. Let's understand the relationship with real-time example. For example, one country can have one prime minister. So what does this mean? One to one. A prime minister can have many ministers, one to many. Also, many MPs can have one prime minister, many to one. And many ministers can have many departments. It's like many to many. So all the concepts you learn are derived from your day-to-day life. Now, let's see or move on to another point, that is aggregation. Aggregation is a way to achieve association. An aggregation represents the relationship one object contains other object as a part of its states, which means it represents the weak relationship between objects. It is also termed as has a relationship in Java. Like inheritance represent there is a relationship. It is another way to reuse objects. And in this diagram that you're seeing, first is association, then the aggregation has a relationship, then composition part of relationship. We'll come to composition now. The composition is also a way to achieve association. The composition represents the relationship where one object contains other object as a part of its state. There is a strong relationship between the containing object and the dependent object. It is the state where containing objects do not have an independent existence. If you delete the parent object, all the child object will be deleted automatically. Which means, let's take an example of student and an address. Student, if the student object is related, then address object cannot be like cannot exist independently, right? So both will get deleted. But student and a teacher, student and teacher has a relation, but they all have their own life cycle, right? So aggregation can be a student has a relationship, but if the student is leaving the school, it doesn't mean teacher has to leave the school, right? So in all, this diagram we are able to understand completely. So we are done with how a relationship can be, means association. And just to end this session, the main thing that I can say is association can be unidirectional and bidirectional as well, right? That we learn from the example of student and a teacher. So happy learning. Subscribe to this channel, like the video, and ciao.